Hello everyone, welcome to my channel. In this video, we are going to learn about the transmission media in the computer networks. So in the previous videos, we have learned about the different OSI model layers and TCP IP model layers. So what is meant by transmission media? So it carries some information from the source to the destination. So here the transmission media, the media will act as a medium between the source and destination. Okay, it will transfer some message from source to the destination. And where does the transmission media exist? The transmission media exists in the physical layer of the OSI model. Okay, so we know that all the layers in the OSI model works based on some software, right? So if you take the application layer, so we can send some emails, okay, the FTP connection, HTTP connections, all works in the application layer, okay. So all the OSI model layers works based on some software except the physical layer. So the transmission media exists in the physical layer of the OSI model. So let us say an example. So two persons are communicating with each other. Okay. So here the two persons are, the persons are we can consider them as a source and destination, right? And the transmission medium between them is air. Okay. And let us say for the wireless, for the wired communication, if you consider for written message, the transmission medium might be a mail carrier or a truck or an aeroplane. Okay, if you are writing a mail or letter, then it will be transferred from one location to another location using a airplane, truck or any vehicle, right? So now let us see the different types of transmission media, that is guided media and unguided media. So guided media is classified into three types, that is twisted pair, coaxial cable and fiber optic cable. So in this video we will discuss about the guided media. So the guided media means a signal traveling along any of these media is directed and contained by the physical limits of the medium. Okay, so here the media is guided, that is it is already destined for the source and destination. Okay, so it is already fixed the path to travel from the source to destination through a particular the message must pass through a medium, so which is already declared. So there are three types of guided media, that is fiber optic cable, twisted pair cable and coaxial cable. Okay, so here the twisted pair cable and coaxial cable, in these cables the transport of signals will be in the format of electric current. Okay, and in the optical fiber cable, the transportation of signals will be in the format of light waves. So that's why optical fiber cable is very faster and it is most recently used for the internet nowadays compared to the twisted pair and coaxial cables. Okay, whereas the twisted pair and coaxial cables allow the electric current to pass through them. So one of the guided media is twisted pair cable. Okay, so it consists of two conductors, each with its own plastic insulation twisted together. Okay, so in a twisted pair cable there are two conductors, that is two wires which are twisted together. Okay, so what happens if the two conductors are not twisted and if they are in a straight line format? So if they are the two conductors are in a straight line format, then it may lead to some interference. Okay, that means there will be more noise. So that's why these two conductors are twisted together. One of the wires is used to carry signals to the receiver and the other is used only as a ground reference. So here in the the twisted cable will be having two wires, right? So one wire will be used to carry some signals to the receiver and the other wire will be acting as a ground reference. Okay. So in addition to the signal sent by the sender, on one of the wires, interference, that is the noise and crosstalk may affect both wires and create unwanted signals. So this is the main drawback of the twisted pair cable. Okay, so in here the signal sent by the sender may go through interference and crosstalk. So the number of twists per unit of length has some effect on the quality of the cable. So based on the number of twists in the twisted pair cable, the quality may increase here. So this is a twisted pair cable. So here the two conductors are twisted together such that it can transfer the data from source to destination. So here one conductor will transfer the information and the other conductor will act as a ground reference. So these twisted pair cables are coated with the insulators. Okay, so these two are coated with the insulators, and inside it the copper wire will be there. That is the conductor, so which will allow the current to pass through it. So there are two types of twisted pair cables, that is unshielded versus shielded twisted pair cables. So these are the two types of twisted pair cables, and the most common twisted pair is the unshielded twisted pair cable. So this is the UTP. So what is the difference between the unshielded and shielded twisted pair cable? So in the unshielded twisted pair cable, so there will be no shield covered upon the two conductors, but in the case of the shielded twisted pair cable, there will be another metal shield that covers the two conductors. So this is the difference between the unshielded and shielded twisted pair cable. Okay. So Electronic Industries Association has developed standards to classify UTP into 7 categories. Okay. So this is the category 1 to category 7. So category 1 UTP. So the data rate is less than 0.1 megabits per second and use is for telephone lines. And category 2 is for UTP-T. The specification is UTP-T and the data rate is 2 megabits per second. Okay. And the next one is category 3. The specification is called as category 2 and data rate is 10 megabits per second and the use is for LAN. And so on, the categories are specified up to 7. The category 7 SSTP 600 and use it for LAN connection. So next one is the performance. The performance is based on the attenuation versus frequency and distortion. And applications. So applications are local loops, digital subscriber lines, LANs, that is for 10 base T and 100 base T. So what is the 10 base T here? So 10 base T means, so here the 10 specifies the speed of the network, that is 10 megabits per second, and base means the baseband transmission. So we have two types of transmission, right? Baseband and broadband. So the base means baseband transmission and T means the twisted pair cable. Okay, so 10 megabits per second. So the speed will be 10 megabits per second. Okay, and after traveling some distance, that is after traveling some the 10 meters of distance, so it will the signal will go through some, so the signal will become weak. So after traveling some distance, the signal will become weak, and base means baseband means the signal will travel in only one direction. So if another signal comes opposite to the baseband signal, then there will be a collision. Okay, and here also 100 base T means it supports 100 megabits per second speed and baseband transmission with the twisted pair cable. So these are the main applications, the twisted pair cable. So next one is the coaxial cable. So coaxial cable carries signals of higher frequency ranges than the twisted pair cable. So coaxial has a central core conductor of solid or stranded wire, usually copper, enclosed in a insulating sheet, encased in a outer conductor of metal foil braid. So coaxial cable carries the signals of higher frequency compared to the twisted pair cables. So here the coaxial cable, so it is covered by, the inner conductor is covered by outer conductor or shield, and the outer conductor is covered by insulator, which is again encased by a plastic cover. So coaxial cables are categorized by their radio government ratings, that is RG ratings. Okay, so we use the coaxial cable frequently in the connecting dish connections. Okay, so for the dish connection we will be using the coaxial cables, whereas the twisted pair cable will be used to connect two systems, or to connect a system to a router, or a system to a hub, or any networking device. To connect a system with any networking or inter-networking device, we use the twisted pair cable. Or to connect two systems also, we will use the twisted pair cable. So these are the different ratings of the twisted pair cable, that is RG59 with impedance 75 ohms, and the uses cable TV, and RG58 and RG11. So this is very important. RG58 is also called as a thin Ethernet, and RG11 is a thick Ethernet. The most common conductor is Bayon-Neal-Conselman conductor, that is a BNC connector. Okay, so the BNC connector is used to connect the cable to a device, and the BNC-T connector is used to connect the device to a Ethernet, and BNC terminator, which is used to connect the end of the cable to a TV set. So here also, similar to a twisted pair cable, so after traveling some distance the signal will become weak. So that's why we are using the repeaters here to regenerate the signal. And the applications here are cable TV networks and telephone networks. So here the main advantage is it can carry maximum speed compared to the twisted pair cable, and it can handle without having any cross stacks, which is a problem in the twisted pair cable. So here the number of twists in the next one is the fiber optic cable. A fiber optic cable is made of glass or plastic and transmits the signal in the form of light. So the previous two cables, that is the coaxial and twisted pair cable, allows the signals to pass in the format of electric current. That is, the analog signals will be passed through the twisted pair and coaxial cables. But here in the fiber optic cable, the light will pass through the glass, okay, through the cable. Okay, so we know that the light will travel very faster compared to the remaining one, right? So the light travels here faster at the speed of 3 into 10 power 8 milliseconds. The light travels in a straight line when it is moving through a single uniform substance. So if it suddenly enters another more or less dense, then the ray changes the direction. So here if you observe in the diagrams, so here the light is passing through a particular medium. So when the light passes through a less dense medium, suddenly then the light will change its direction, right? So here also, so the light is passing through the more dense medium. So after changing when the light ray changes to a less dense medium, then it will change the direction. So it will change the direction in any side. So based on the medium, it is a transferring. Okay. So if the I less than critical angle, it is called as a refraction, and I equals to critical angle, it is called as a refraction, and I greater than critical angle, it is called as a reflection. Okay. So if the light ray travels within the dense medium, then it is called as a reflection. And if the light ray passes through one more dense medium to less dense medium, it is called as a refraction. So this is optical fiber, so which is having a cladding of a glass material. So the cladding will be same for the different types of modes, the cladding will be same. Okay, so this is the optical fiber, and the sender is sending some information in the format of, the message will be converted into the format of light ray. Okay, and it enters the optical fiber here. So due to the property of reflection, so the light is reflecting within the optical fiber, and it reaches the receiver. So there are different types of propagation modes in the optical fiber cable, that is multi-mode and single mode. Okay. And the multi-mode is again divided into two types, that is step index and graded index mode. Okay. So in the multi-mode step index, so there will be more reflections within the optical fiber cable. So what is meant by multi-mode and single mode? The single mode, in the optical fiber cable, the single light ray will travel without any distractions here. So the single light ray is traveling through the optical fiber cable. Whereas in the case of the multi-mode, so there will be multiple number of light rays that will be travel through the optical fiber cable. Okay, so in the multi-mode, so there will be multiple number of light rays that will be traveling through the optical fiber cable to reach the destination. So these are the two types of the multi-mode optical fiber cable, that is step index and graded index. Next, coming to the applications. The transfer data rate of optical fiber cable is 1600 gigabits per second. That is the maximum speed. And another application is LAN, such as 100 base FX and 100 base X also use fiber optic cable. Okay. So the world is entirely covered with is communicating using the fiber optic cable. Right? So the internet is we are using the internet all over.